myth, he's the legend, he's the scientist with all the answers to all the questions. It's time for another episode of Alex's Science Corner.
Thank you.
Alex, what's going on in the wide, wide world of science, my friend?
Okay, I'm going to talk about a story that's been hitting all the big science news sites I go to, and it's been blowing up on the science news sites, but it hasn't gotten into the mainstream media because it's kind of a difficult topic to explain. But we're going to start the story with last week, April 24th, was the Hubble Space Telescope's 29th anniversary.
It's been up there that long.
Yes, it has. It was released into space on April 24th, 29 years ago.
Higher math.
Yeah. I know. It's 1990 that it was launched. So the Hubble Space Telescope is named after Edwin Hubble. And we're going to start the story with him. When Einstein came up with the theory of relativity and they were looking at all the stars and galaxies, they assumed that everything was kind of static. You know, the stars kind of stayed, orbiting around our galaxy, but, our galaxy was everything in the universe. But Einstein's theory of relativity said that all this stuff should be coming together. So why isn't it all coming together? So he put in this little number in his equation for a constant to keep everything separated out so nothing's like coming together. Well, then Edwin Hubble, I know, Bobby, you have an Albert Einstein book.
With me right now.
Yes.
On relativity.
Yes. So Edwin Hubble did a lot of work, and in 1920, he discovered that a lot of these nebula are not actually nebula, they're actually other galaxies. The Andromeda Galaxy used to be called the Andromeda Nebula, and they thought it was a nebula. But he figured out that they're galaxies.
What's a nebula?
Nebula is a dust cloud. Okay. Those pretty pictures that you'll see on various things like the Space Telescope of cloud-like formations in space, those are nebula.
Okay.
So this is as a result of the Hubble telescope that we discovered this, or this was
No, this is Edwin Hubble in the 1920s.
Okay.
Discovered that there are galaxies outside of our galaxy.
Let's see. Okay.
And one of the other things he discovered was that these galaxies are moving away from each other. And how fast they're moving away became known as the Hubble constant. Now, they had expected that eventually everything would collapse back in together. Einstein said, well, I don't know why it's not collapsing back in together, so I've got this number that I'm going to put in the equation just so that everything stays apart. And he called it his biggest mistake because he didn't want to put in the constant, and his actual biggest mistake was the constant was correct. He actually was correct, and his mistake was thinking that was a mistake. So Hubble figured out that these galaxies are all flying apart. For decades, astronomers and physicists were like, okay, we know that everything's going apart, but gravity is eventually going to start pulling it back together. So now we want to figure out how long it's going to be before everything starts coming back together. In the late 1990s, because of the Hubble Space Telescope, they figured out that these galaxies aren't just moving apart from each other, they're accelerating away from each other. So that they're moving faster and faster away from each other. And
hence the universe is expanding.
The universe is expanding. So it's like put two little dots on a piece of rubber band and pull that rubber band apart. The space between those two dots is moving apart. The two dots are staying together as dots, but the dots themselves are separating out from each other. And this was a big discovery about 20 years ago that it's not just that we're moving apart, but we're moving apart from each other faster and faster and faster. So they've been doing these calculations. For the past 20 years, they've been doing different ways of measuring the universe, trying to figure out what is the exact number that we're moving. So one of the ways they're doing is looking at the old background radiation of the universe as far back as we can see, and they calculated out a number. And they were looking at closer items and calculating a number from closer by looking at stars and galaxies that are closer to us. And the errors, it's like the calculations weren't great, but they got a number, and it's like they weren't exact, but the error bars between those two calculations were within each other. Well, what's happened in the past month is there's several papers released. The error bars, they're getting better and better at making all of these measurements. And the error
In
bars
other words, the error is getting smaller,
smaller and smaller. And now the error bars are no longer crossing. And what that means is that the number we have from the early universe as how fast the universe is expanding is different than how fast the universe is expanding now. So it's like acceleration. You're going 10 miles an hour. Every minute you're accelerating by 1 mile an hour. So like at first you start 10 miles an hour. 1 minute later you're going 11 miles an hour. Next you're going 12 miles an hour. You can calculate how fast you could be after 10 minutes. This acceleration is different. We are speeding up faster than we were speeding up before. And this is the mystery. Because right now physicists are going, all the stuff we say about physics is from the early universe says we should have this number right now, but the number is much, much higher now than what it should be. And again, this is one of those challenges. This is why you probably haven't seen it in the latest news. It's blowing up in the science news thing, but in the general news you haven't seen it because this is a tough thing to try and explain.
Tough concept to, yeah.
Right. But it is a fundamental constant that they calculated out that is different now than it was then. They say great discoveries are usually preceded by not eureka, but that's weird.
I've heard that before.
Yeah.
Yeah, so that is the story for this week.
So the eureka comes after the that's weird. First you get the
that's
weird,
most
and then you get
that's
eureka.
weird is something. A scientist has been studying something, sees something weird. That's weird, and I'm just going in there and trying to figure out what it is.
Eureka is pretty rare.
Yeah, eureka is very rare. The way you find discoveries is you start with that's weird.
I wonder if, what if, kind of thing.
Yeah, and again, that's just a big news story within the science community because we've got these two numbers. We've got different ways of measuring these numbers, and it's supposed to be the same number, and it's not.
Is there a physicist in the house?
Yeah.
Anybody channeling Stephen Hawking?
All right. Anything else to add to that?
I just got one question.
Sure.
So Stephen Hawking did do all this research on black holes. How are the black holes affecting all this? Because black holes were supposed to be pulling things into them.
Right, but black
So I
holes
would
are
have
just...
thought that they would have been balancing off this expansion.
Well, you got to think about it as a galaxy because black holes are small dots inside of a galaxy.
Okay.
So when you're talking about something the size of a galaxy, galaxies still can affect each other. For example, Andromeda Galaxy and our galaxy are going to crash together in about, I think about 1 billion years from now. They're going to crash together because they're close enough for the gravities to affect each other.
Okay.
Galaxies that are a lot farther apart, like we have what's known as our local group of galaxies. Us, about 3 or 4 of the galaxies plus Andromeda are part of the local group. Those are close enough that the gravity between these galaxies is strong enough
To have an effect
on each other, and that effect is greater than the part where the universe is trying to separate us out.
Okay.
Galaxies that are farther away than that are not close enough. So even though their gravity may affect us, the universe between us and them is expanding faster than the gravity can pull us closer together.
Okay.
Okay?
All right. If you have any questions about this story or anything else science related, feel free to call Alex right now at 203
837
99
24.